Alright, here we go. Harder difference of two squares. Now we might as well start with the do now and make sure we're okay. Alright, so key thing, GCF. Always take out the GCF. 3, let me get a pen going. 3WK, which leaves me with 35K to the fourth minus 9, not W, took that out, K squared minus 2. Alright, big question. What factors of negative 70 add to negative 9? So I got negative 14 and 5. So 3WK, 35K to the fourth minus 14K squared, 5K squared minus 2. Alright, so put that off to the side so I don't forget about it. GCF, 7K squared, which leaves me with 5K squared minus 2. Got to take out something. Always have to take out something. So here, take out a 1. Leaves me with 5K squared minus 2. 5K squared minus 2. 7K squared minus 1 plus 1. And 3WK in front. Alright, so, and with everything, GCF, key thing, take it out. Right? Always look for the GCF. Right? Always, is the problem actually done? Can you take the problem a step further? And the last key thing, put the GCF back in front. You don't know how many people forget to put the 3WK back in front. Such a silly little thing to lose points on. Alright, so we are taking difference of squares and taking it to a whole nother level today. So everything we talked about the other day still holds true. A minus B, A plus B, this is prime, we got binomial, we have subtraction, we have perfect square, and we have even exponents. Alright, here we go. So, someone looks at this usually, and I know the first thing a lot of people think is option 1. I'll just FOIL this together. X plus 5 times x plus 5 minus 36, x squared plus 10x plus 25 minus 36, x squared plus 10x minus 11, and we're good to factor. X plus 11, x minus 1. Perfect, works. But if you look at the example below, not going to work there. Right, not going to work. Right, so we got to treat this exactly the way we see it sometimes. So for my option 2, I think about this as, this is actually x plus 5 squared minus 6 squared. Right, which goes with our form a squared minus b squared. Something squared minus something squared. Well, here we have x plus 5 as the something squared, and we have 6 as the something squared. So if we take this and do difference of squares exactly the way we know how to do it, it would be x plus 5 minus 6 times x plus 5 plus 6. No different than what we've already done in the past, which simplifies down into x minus 1 and x plus 11. So in this situation, both methods give us the exact same answer, but option 2, that's what we're working towards right now. Right now, a second idea that could help people out is this. If you just don't, if you don't like what you're seeing right now, you could do a cheat method where you say something like w equals x plus 5. So you can make this w squared minus 36, which would be w minus 6, w plus 6, then sub back in x plus 5 minus 6, x plus 5 plus 6 to get you back there. All right, so we're going to focus more on that method later on in the unit, but I'm just throwing out ideas for people that might be stuck right now. So if we look at this example, option 1, can we do option 1? Not possible. So we have to go with the option 2 from the previous problem. All right, so the question is, Right? The question is, where is my squared piece? So I see here that 25y squared is 5y squared. Now the only way this will work is if we factor this. Well, we're in luck, because x squared plus 6x plus 9 becomes x plus 3 times x plus 3. If that wasn't the case, we could not do this problem. Right? So that is a perfect trinomial, meaning that the two bubbles we get are exactly the same. So since we have it like that, we can do this. X plus 3, x plus, I wrote a 5. X plus 3, no, I gotta highlight, I'm a mess. I'm losing it. X plus 3 minus 5y. X plus 3 plus 5y. X plus 3 minus 5y. X plus 3 plus 5y. Nothing to combine here, but there we have it. All right, so we're finding the perfect trinomials. Now, if there was no perfect trinomial, we couldn't do this. If this factored down to x plus 3, x plus 6, not happening. Only works if there's a perfect trinomial in the problem. All right, so why are we not working here? Uh-oh, I'm frozen. All right, there we go. All right, getting harder, getting more up to the level we're looking at. All right, so if I'm looking at this problem right here, what's my first rule? First rule of the problem, GCF. All right, so I gotta go with the GCF. GCF of AB, which leaves me with a squared plus b squared minus 2ab minus 1. So I take my GCF and put it off to the side like I always do. Now the question is, where is the perfect trinomial? All right. So is this a perfect trinomial? No. Is this? No way. So for a problem like this, we have to reorder. So I see it. My perfect trinomial, a squared minus 2ab plus b squared minus 1. This breaks down into, obviously, 1 squared. And if I FOIL this, a minus b times a minus b for a minus b squared. All right, so by reordering it, I found my perfect trinomial, which gave me the opportunity, this should be squared, to actually do this. So I have a minus b minus 1, a minus b plus 1, and I cannot forget about my GCF that goes in front. So we've looked at things with 4 terms. So previously, if you had 4 terms, it would be a grouping problem. But now if you have 4 terms, you have this new idea. Maybe it's a perfect trinomial. Okay, so hint, GCF to group. All right, so I'm looking here. What's my GCF? It looks like I can take out a 3x. If I take out a 3x, I got 64y squared minus x squared minus plus 8x minus 16. All right, so obviously, I look for the odd man out. 64y squared is obviously the odd man out. That's on its own. All right, but what do I do with this? How am I going to factor that? Well, the problem is that we have to group it as a singular piece. So I personally like the GCF to group to get that perfect trinomial in front. So if I could modify this problem, I would have GCF to negative 3x. By doing that, I'd have negative 64y squared plus x squared minus 8x plus 16 And by reorganizing it, x squared minus 8x plus 16 minus 64y squared, there's my perfect trinomial. Now I'll go back and show you from the original problem, the way we did it, how it would work. So this factors down to x minus 4 squared minus 8y squared. X minus 4 minus 8y. X minus 4 plus 8y. With that negative 3x in front. So I kind of GCF the group, and what I mean by that is I try and get the perfect trinomial in front. I want the random thing in the back. Now if I go back to what I did with the 3x, the move you have to make here is this. So I have obviously the 64y squared, but I have to group the back pieces to make the perfect trinomial. So if I GCF a negative, x squared minus 8x plus 16 is now inside of the parentheses, which gives me 8y squared minus x minus 4 squared, 8y minus x minus 4, 8y plus x minus 4. Distribute the negative, 8y minus x plus 4, 8y plus x minus 4 with the 3x in front. Now both of these, they look different, but they actually represent the exact same thing. Right? No difference here. Right? These two bubbles are exactly the same. And if we GCF the negative 1 from here, they would make a negative 3x and they would line up identical. Doesn't matter which way you do it, whatever you're most comfortable with, go for it. All right, even harder. Okay, so I'm looking here, problem 5. I know in this situation, this is the odd man out. Right, it's the odd man out. I gotta do something to the other pieces. So as I talked about in the previous work, I want to GCF to get those pieces in front. So instead of taking out a 2, I'm going to take out a negative 2. That gives me negative 25 plus 4a squared minus 12ab plus 9b squared. Put that off to the side. Now the negative 25, it's going in the back. 4a squared minus 12ab plus 9b squared minus 25. Got my two separate pieces. I factor here. All right, so what I got, 2a minus 3b, 2a minus 3b, which gives me 2a minus 3b squared minus 5 squared. So I have 2a minus 3b minus 5, 2a minus 3b plus 5 with a negative 2 in front. All right, so I always look for that odd man out in that piece. I want to throw that piece to the back. Personally, I'm not the biggest fan of this method up here where we're GCFing inside what we've already GCF'd. I'd rather take out a negative to reorganize it right away if possible. Okay. All right, looking here. What's my GCF? My GCF is 3A. It looks like 3A. Which piece looks like it's the odd man out? Undecided at the moment. Which piece is the odd man out? So if I take out 3A, I got 12a squared x minus 4a squared. Oops. Minus 3b squared x plus b squared. Alright, so looking at this, where's the perfect trinomial? Here's the kicker. It's not a perfect trinomial, right? In this situation, pull my GCF off to the side, I have it set up where I can do grouping, right? Just because it's 4 terms doesn't mean it's a perfect a difference of squares. It's a grouping problem. So I take out my GCF here of 4a squared leaves me with 3x minus 1. Over here, I take out my GCF of b squared, leaves me with negative b squared, leaves me with 3x minus 1. All right, 4a squared minus b squared, 3x minus 1. All right, got my GCF in front. All right, so it may not be a difference of squares. If it's 4 terms, you got 2 options. And now, know what I realize here? It's not done. The problem's not done. It can go further. 3a, 2a minus b, 2a plus b, 3x minus 1. All right, finish the problem. Finish completely. All right, look in here. What do I see? Who's the odd man out? I see it. The odd man out, negative 81. So if I reorganize, 9x squared minus 42xy plus 49y squared minus 81. All right, so if I factor 3x minus 7y times 3x minus 7y, 3x minus 7y squared minus 9 squared. I'm sorry if I'm, going through the factoring quickly. I see it. I've been doing factoring. I do factoring for a living, so I see it a little bit better than what some people do. All right, so I got 3x minus 7y minus 9, 3x minus 7y plus 9. There's my answer. All right, problem 8. Obviously, right away with problem 8, it's not a harder difference of squares. There's only 3 terms. All right, there's only 3 terms in this situation. All right, so I'm looking at it. First rule of factoring, GCF. I'm taking that in this situation 2x. 27x to the 4th minus 33x squared y to the 4th minus 4y to the 8th. All right, so split the middle term. 27 times negative 4, negative 108. What factors of negative 108 add to negative 33? Negative 36 and 3. Toss you off to the side. So I got 27x to the 4th minus 36x squared y to the 4th plus 3x squared y to the 4th minus 4y to the 8th. Group. GCF of 9x squared, 3x squared minus 4y to the 4th. GCF here of y to the 4th leaves me with 3x squared minus 4y to the 4th. 2x, 9x squared plus y to the 4th. 3x squared minus 4y to the 4th. And done. Nothing goes further. Alright, we're almost through. We're almost through all our factoring rules. We're getting close to the end.